All right, good day, everyone. This is Jason Straight with the Cloud Pass Virtual Group. Our presentation today is Azure Machine Learning for the absolute beginner, and our presenter is Alexander. Before I hand things over to him, I'm just going to go through a few announcements. So the first announcement is that this virtual group is sponsored by Microsoft. Microsoft sponsors the group to help everyone learn more about building out data platforms in the cloud. If you are not yet a member of the virtual group, I do recommend becoming a member. The way to do that is just to subscribe over at cloud.pass.org. If you're not a member of PASS, you'll need to become a member of PASS first, but then once you subscribe to the virtual group, you'll get our newsletter, which comes out, lets people know when new presentations are coming up, and I generally will send out about, I think it's on average, one newsletter a week that basically covers the upcoming presentations. Speaking of upcoming presentations, for this year, we have 9 more already scheduled over the next few weeks. So I'm always looking to build up the schedule, trying to do 2 a week all the time. So if you are interested in presenting, you can send me an email at cloud@pass.org, or conversely, you can also go out to Cloud Virtual Group website and click on the link for a call for presenters. I had one person send a session in just that way just the other day, so that's a great way to submit your information. And from a presentation perspective, we're always just looking for things that are basically technology and stories around bringing data to the cloud. If you missed the PASS Summit 2019, you can get all of the recorded sessions from the PASS Stuff website. So it does allow you to get the streamable downloads from all of the recorded sessions. This virtual group is part of a number of virtual groups that PASS helps to support. These focus on different languages like Global Chinese and Global Hebrew, trying to help people get more exposure to technologies in native tongues or native languages. And it also, they focus on different technical aspects such as data science and this one, the cloud. Throughout the session, if you have any questions, please type them into the question panel. At the end, we'll go through as many questions as we can and give you an opportunity to ask what you want about the topic today. And the topic today is, of course, Azure Machine Learning for the absolute beginner. And Alexander is our presenter, so let me make him the presenter now so that he can share his screen. All right, you should have it there.
There we go. Hopefully you see what I see.
Yep, it's coming
through. All right, it is coming through. The magic of the cloud, so to speak.
That's right.
All right, I will kick it off. So this is Azure Machine Learning for the absolute beginner. This is not a deep dive in any way, shape, or form. It is for the absolute beginner. It turns out that of all the sessions that I've done over the years, this has been one of the most eye-opening for most people who I generally do not talk to, because I generally talk to more tech-oriented people. So just to set the stage, it is a level 100. You don't really need any, I was about to say preconceptions. Everybody has them about the AI and stuff like that, but you really don't need them, because I'm going to build a few for you. So for starters, would you say that machine learning will cure cancer? No, I don't think so. Because that's like saying a hammer or a screwdriver will build a house. Will machine learning be one of the tools we use to cure cancer? Oh yeah, that I definitely believe. That's also a key concept when it comes to the whole machine learning thing. It is a tool like any other. It is a very, very powerful tool, but it's still just a tool. It's completely useless on its own, and it's up to the artisan wielding it to find its true potential. So we're going to go through introducing machine learning. What is it? What can you do? And how do you get started with this beast known as machine learning in Azure? And how can we apply the machine learning concepts to reality? How do we actually make any use of this? So machine learning is pretty much popping up everywhere. I mean, everyone and their cat wants to have some kind of machine learning algorithm or AI algorithm. Uh, it's like any other hype. Take blockchain or cryptocurrencies, for example. Everyone was talking about them, and for some reason, or I was about to say in some way, they're still doing that. But they were talking about it like it was the solution to all the problems. It turns out that was maybe not the case, simply because they're also just tools. And the trick is to find what the tool can do and then apply the tool to your specific problems. And my goal today is to give you an overview what this tool can and very, very clearly cannot do, and get you on the way to learn how it can benefit you in solving your problems. My name is Alexander. I am from the cold and dreary place known as Sweden. No, it is not Switzerland, because we don't have any chocolate, and we don't build any watches either. We have a crap ton of snow though. I am a principal solutions architect at a company called Atea. It's the best title I've ever held because nobody knows what I do. And what I do is basically I make data matter, because only data that matters can actually impact anything. So I specialize in Power BI, SQL Server, databases in general, anything data really, to further whatever goals we have. I'm a data platform MVP. I am a speaker. I go all over the world to speak. I spoke at Ignite this year, or 2019, I should say. I try to have a blog. I am a terrible blogger. I do a podcast known as the Knee Deep in Tech, and I did a Pluralsight course on Power BI. It was actually relevant for all of 2 weeks. Then Microsoft changed most of what my course was about. I am not at all bitter. So, machine learning, according to Wikipedia. Machine learning is the scientific study of algorithms and statistical models that computer systems use to progressively improve performance for a specific task. Yeah, what does that mean? Well, let's dig slightly deeper. Key takeaways here are progressively improve and specific task. It gives us some kind of idea how this tool behaves. Well, we can look deeper. Machine learning algorithms build a mathematical model of sample data known as training data in order to make predictions or decisions without being explicitly programmed to perform the task. That's a lot of text. And the key takeaways here are training data and without being explicitly. This is thus where the whole artificial intelligence aspect of machine learning comes into play. What's the difference between artificial intelligence and machine learning? Well, artificial intelligence is hype and machine learning is actually being used today, roughly speaking. There is no such thing today as general artificial intelligence, i.e. self-aware machines. It is just algorithms that behave in a very, very specific way. So in short, there is a heck of a lot of buttons and knobs to turn and twist. So let me give you an example, see where we end up. Most of us have been to school, and some of us actually thought that was a pretty fun time. And we've all been to a cafeteria at school, right? So picture this, picture a cafeteria where we grab a set of scales, slightly more modern than this one, but this set of scales has a port that I can plug a networking cable in, and I can upload whatever I weigh on it up to Azure. And then I make sure that all the kids, they weigh their plates when they have grabbed some food and whatever they want to have, weigh that plate before they eat and after they eat. That way I know how much food has been consumed at any given day, right? Then I can connect this to, for instance, a calendar. So this means that I know on a Tuesday in March, I consumed this amount of food, or in a Wednesday in June, I consumed this amount of food. We can keep working with this and keep adding properties. For instance, we can take the weather. I mean, it might be raining in April, or it might be snowing in December, depending on where you are. Or we can go with demographics. We might have a school in an area with a predominantly Asian population or Indian population, or Native American population. All of these bits and pieces are data points, and all these data points can be used to create an algorithm to predict what would be the best kind of tool, food for kids on a, I was about to say Saturday, and very few people go to school on Saturday, but say a Tuesday in Massachusetts in a specific area, and it is April. All of these things together is going to give me the perfect food, and perfect in this case meaning I have optimized towards as little being thrown away as physically possible. Now, the issue with this is not necessarily the right food, as in the most nutritionally valuable food. Anyone who's ever had kids and done some cooking for kids or given kids food at all knows that chocolate is a very, very good thing to give to kids. They like chocolate and they're probably going to eat all of it. Now, chocolate has a lot of excellent properties. Unfortunately, chocolate is not known for its nutritional value. So one key takeaway here is the fact that I can make you an algorithm that is going to give you the preferred food, but not the right food, because the algorithm in itself does not have a clue what it is about. And that is a pretty important concept. We're going to see that coming as we move forward. So what we're actually doing here is we're using statistical models to find a pattern in the data and use that pattern to predict outcomes where we don't have any data. Okay, so the question immediately pops into my head is, can I get a completely new menu out of this? So the basic answer at this level is no, you can't, because that's not the way the algorithm works. The more advanced answer and way more fun answer that this primer will not cover how is, of course, you can get some very, very interesting recipes. I mean, look at this list. This is a list compiled by a research scientist named Janelle Shane, and she basically fed a neural network a lot of data and asked it to come up with new names for recipes. And a beef soup with swap beef and cheese, that sounds pretty interesting. Or how about a crim grunk garlic cheese or garlic cheese? I don't even know what it is. And that also drives home the point that the algorithm does not have a clue of what it's doing. It is only doing predictive analysis in this case. It's hilarious, but it's also kind of dangerous if you don't know what it comes up with. So how does it work? How does the whole thing work? I'm very happy you asked that. And before you ask the other question, this is Japan. They have a very interesting, or should I say, creative way of wiring things, kind of like the water pipes in the UK. But I digress. So the answer to this question depends on a few things, and we need to start with two key definitions. One is a model. And what is a model? A model is a mathematical representation of a real-world process, right? And to generate this model, we need to provide training data to an algorithm to produce something. And of course, which algorithm is the best? Well, it's like asking which color is the best. Kids are going to have the answer, but adults, we know that there is no such thing as the perfect color, the right color. And that's the same with the algorithm. There are generally three kinds of learning in machine learning. So we have what is known as the supervised learning for starters. And this is also divided into three main areas. And these are classifications, which is when we are trying to categorize something. Regression, which is a fancy word for saying a predicted value. And anomaly detection. Now, let me give you an example of anomaly detection. I like Star Wars. I really, really like Star Wars. So this I keep saying this year. It's actually last year. Last year I was in Chicago for the Star Wars celebration. Just imagine 40,000 Star Wars fans. Yeah, it is that epic. And I went in to buy a cup of coffee at a Starbucks. So I ordered my coffee and I swiped my card and it was declined. I mean, come on, it's a credit card. How can it be declined? And like 15 seconds afterwards, my phone rang and it was a Swedish number. So I picked it up and said, yeah, hello. Yeah, hi, this is your bank calling. We see that you are in Chicago and you're trying to pay for a cup of coffee. Is this correct? Yes, it is. Awesome. We have reinstated your card and we are sorry for the delay, sir, but you're generally in the West Coast of the US when you're in the US. So we thought this was kind of unusual, so that's why we decided to call. Thank you. Have a great day. That is anomaly detection. I am definitely almost always on the West Coast, somewhere around the Redmond area. And for the first time in my life, I was in Chicago and immediately the system caught this as an anomaly. And that is something that the machine learning algorithms are extremely good at. There's also something called, oh, before I get there, how do you choose one? Well, this is the algorithm cheat sheet, and it is a good starting point. There's no such thing as the perfect algorithm, and you can ask any data scientist. They're probably going to go, yeah, for this specific problem, you probably want to have this. But a pretty important step in the whole process of using machine learning is that you're probably going to need to try things out. If you are going to do regression, and let's just look at the cheat sheet here. So if we are predicting a distribution, a fast forest quantile regression might be a good one, but it's not necessarily the perfect algorithm for your specific use case. But this cheat sheet gives you somewhere to start. Then we have unsupervised learning. And while in the supervised learning, I explicitly tell the algorithm what to do and show it a bunch of training data to work with, the unsupervised learning, we don't have any data that had any labels with them. So the goal of an unsupervised learning algorithm is to organize the data in some way to describe a structure. And this means that it can pretty much learn as it goes. And this can have some pretty interesting results. Let me give you a few examples. The first one was when the data scientists created an algorithm to do a landing, a plane landing in a flight simulator. And it didn't take the algorithm very long to figure out that by creating large forces that was estimated to be zero due to a bug in the flight simulator, it resulted in a perfect score. So again, it doesn't have a clue what it is actually doing, but it's going to try to find a pattern or anything that it could exploit to get the result that we are asking for. In this case, we were asking for it to land the plane, and according to the specifications, this was the best result that it could have. So it found a way of breaking the flight simulator. Let's try something slightly simpler. Let's teach you to play Tetris. Now, what was the goal shaping or reward shaping in this case? Well, it was don't lose. So what did it do? Well, it paused the game, because if it's paused, it's not gonna lose. Or teaching it how to ride a bike, and the reward shaping in this case was not falling over. And it was also making progress towards a specific goal point. Unfortunately, it wasn't punished for moving away. So that meant it found a way of going in a circle, or either a circle or a figure eight, because that was a stable loop. It wasn't getting closer, it wasn't getting further away, and it wasn't falling over either. So according to the specifications, we set the algorithm came up with a way to satisfy those specifications. And this is also a key concept with machine learning. You must be extremely careful with the way you reward shape, because as you ask, you are going to get an answer. I have a good friend who is fairly thoroughly autistic, and he is extremely smart. But some things are more difficult for him to comprehend than others. If I, for instance, say, can you open the window? He is going to answer very truthfully, yes, I can. And there is no sarcasm at all in there. I asked, can you open the window? Then he answered, yes, he can. He did not realize that I implied, could you please do so as well? It's the same thing with machine learning. The third kind is reinforcement learning, and that is kind of bringing supervised learning and unsupervised learning together in a mixer kind of thing. We don't have this in Azure Machine Learning as of yet. It might come, I don't know at this moment, but just know that reinforcement learning does not exist in Azure. So what is this training data anyway? Well, it can be pretty much anything you want. And anything that you think that can have an impact on any given question is considered data, and you can use that as training data. But the quality is paramount, because the model will only work with the data you show it. And the old adage of garbage in and garbage out is very applicable here, because everything you show the model is going to try to fit into a pattern. And as I'm going to show you in a bit, it is probably going to find a pattern. And it doesn't matter if the pattern is actually there or not. More about that in a second. So again, what about this quality thing? What does it really mean? Well, in a word, it means everything. The data must be clean and correct for the model to be able to learn from it. And here it is always interesting depending on who you're talking to, because I came up through databases. So quality for me is, for instance, I abhor nulls. A column with a lack of a value, that's a null value. I hate that, because I don't know if it is supposed to be a 0 or if it is not supposed to be there at all. I don't like inconsistencies. I don't like not knowing. But if you were talking to a business analyst, quality might mean something completely different. Quality might mean that you're using the exact right labelings. I don't know. So it's extremely important to be cognizant of what are we talking about. We need to share a common language. And this is also one of the more sinister aspects of quality, that quality can bite you in the posterior if you don't really know that everybody is on the same page. And consistency is important when you have kids, right? And the more variations and situations the model or the kid is shown, the easier it is to find a pattern to apply this new knowledge. And consistency is key. If mommy says that this is okay when daddy says it's not, well, that's an inconsistency. And if the kid goes to mommy and says, well, daddy said, and daddy never did say that, that's another inconsistency. So be very clear on what you show the model and what you do not show the model. So how much data do you need? Well, that's easy. Way more than you think. So I've been asked by my clients to create an algorithm that does whatever from a data set that they provided, and that data set was 150 rows. Now, as I'm going to show you in a bit, using too few rows is going to introduce a few issues in your model, which is kind of what I want to show you in the demo. But you're probably going to be looking at thousands and thousands and thousands of rows of data, if not millions or even billions, if you really want to find a good pattern. So the more data you have, the better. But the more data you have, the more compute power you're going to need to crunch through all this data and find the pattern. But Think for yourself. The more pixels you have in a picture, the more detail you can create than if you have like the old 8-bit Nintendo graphics. They are pretty vastly different from a 4K image. It's the same thing here. So machine learning can be a bit of a black box. Yeah. How about, let's go through a demo. I can show you how this comes together. It's surprisingly simple. One of the main issues with this whole black box thing is that depending on the algorithm you're using, you may or may not be able to deduce how it actually came up with something. And that is dangerous. And voices have been raised that some types of algorithms, for instance, the neural networks, that really is a black box. You have an input, something happens in the middle, and then you have an output. As you cannot ascertain how it came to a specific conclusion, that is kind of a dangerous way of doing things. It is very well suited for image recognition, but maybe not for other kinds of decision support systems. So what do we do before or what do we need to do before we can actually do the demo? Well, here are the steps that we need to walk through. We start with getting data from somewhere. And this can be CSV files, comma separated values. It can be database. It can be anything we have in the data lake. It doesn't matter. We need to have some kind of data. And then we clean this data. Again, this is absolutely key. The data needs to be as good as we physically can make it, because all the scraps of bad data or inconsistent data, whatever issues we might have in the data, is going to impact the end result. And this can be subtle. Even small changes or small issues can be a definite problem. Then we train the model, and we train the model by showing it most of the training data, most of the data. Not all of it, but most. And the reason why we keep some data away from it is that we are able to use the withheld data to validate the model on data that it has never seen. And then when we're done, we get to do the whole thing again. Because a lot of times you're going to find that you need to repeat a few of these steps over and over and over again to refine the model and get further and closer to where you want to go. So how do we get started? Back in 1995, a data set with 569 patients were donated to the University of Wisconsin. This data describes characteristics of cell nuclei present in this image. And this means that all these colors and information in here are then turned into a textual representation, and it looks like this. Now, all in all, these are 32 columns, all columns with a specific property of this cell sample. I used to be a paramedic, so I have a lot of knowledge about emergency medicine and pre-hospital care, but I have almost zero knowledge of histology or pathology, so I won't try to explain the values, and that's kind of beside the point. We don't need to think about that. But there are two columns in this data set that we need to take very, very, very specific care with, and that's these two columns. The first one is patient ID, and patient ID has no impact at all on anything. So that needs to go the way of the dodo. We need to take that out, because otherwise it can seriously skew or impact the whole algorithm. The second one is pretty much what we're trying to predict. That's M for malignant, which means a less than positive outcome, or B for benign, which is a good outcome when it comes to oncology. So the second column is what we want to predict. The first column is what we need to take out. And all the other columns are what we need to feed to a model in order for it to make a prediction. Let me show you how. This is the Azure Machine Learning Studio, and while it might not look exactly this way anymore, because these things change. If you, whatever you do, if you're working with Azure, never go on vacation, because when you come back, half of it is going to be changed. Yeah, seriously. But it's kind of the same thing. So we're starting here in experiments, and I'm going to create a new experiment by doing a blank experiment. And I'm going to call this breast cancer demo because that's what we do. And this is a canvas. We're going to use this canvas to step-by-step create this model. So we're starting with the data set that I have very conveniently already uploaded. This is a CSV, or a comma-separated file, just a normal text file. We drag that into the canvas. Having done that, it's time to do some housekeeping, because we want to do some things that I just told you about. I want to select a specific number of columns, right? And what do I want to select? I want to select all the columns that are not column number 1, because column number 1 is the patient ID, and we don't want that going forward. Having done that, it's time to go and split the data. And splitting is all about taking one part to train the data and one part to actually evaluate this data. And by default, this is going to split 50-50. And with this small data set, it's a better choice to do 25% and 75%. So I'm going to withhold 25% as opposed to 50%. Having done that, it is now time to do some actual training. And I am dragging out a train model, connecting that to the split data. And what I need to do next is to choose what to predict, or what to train for. And that I do by going for the column selector here over to the right. And column 2 is my predictor. That's what I want to predict, right? So I want to take all the other columns and predict column number 2. Having done that, it's time to score the result. And scoring is basically taking the result of the training and comparing it to the data that the model has not seen. And well, there you go. That's kind of the skeleton, or the basis for what we need. We're kind of missing one thing though. We're kind of missing the whole brain of the outfit, and that is the model itself. Now, this is a classification. It could technically be a regression, but I'm going to go with a classification because I just have 2 options, B or M. And I have a lot of different classification models that I could use, but I'm going to go with the 2-class boosted decision tree, simply because it sounds awesome. Yes, that is the truth. That's why I chose it. So there we go. Let's press play on tape and see what we can see. We start this whole model run, and data is going to flow from the CSV file all the way through the steps. And when we're done, we can look at the scored model. And as you can very, very clearly see, it's a pretty good model. It's not without its issues, but it's pretty good, as you can see here. Yeah, I can see you shaking your heads. It's hard to read this. If you're a trained statistician, I'm sure this is basic. I am not. Anyone can tell you that I am horrible at math. So let's do an evaluate model instead. This takes away a lot of the difficulty in interpreting what we just saw from the scoring output. So we try this again, we run it again, and when we're hopefully done, though we can go and visualize the result of the evaluation instead. And aha, this is a whole different kettle of fish. So we can see here, we have 57 true positives and 2 false negatives. Hurdle number 1, what is positive and what is negative in this context? A positive label is malignant, and that has nothing to do with the fact that malignant is not a positive outcome. But for the sake of this specific machine learning run and algorithm, the label for positive is M. So this means we have 57 true malignant cell samples. We also have one false positive, one falsely positive malignant. That's an issue. But what is even more issue is the fact that we have two false negatives. And negative in this case is benign. So this algorithm is going to miss two cancers. And here we can see two things. One is the result of a very small data set. We only have 569 patients. That is way too small a data set to create a good model of, in this case, breast cancer. And the other one is that if you cannot, if you don't know what this thing does under the hood, you cannot come up with how it came up with these numbers. Thus, you cannot entirely trust it. So be very, very cognizant of the fact that this is not perfect. I would go as far as to say, be careful about trusting a machine learning algorithm too far. Trust is good, but control is better. So just be aware, we're going to have some issues. But having said that, we are still at like 97.4% accuracy. If you want, we can scroll down a bit and see even more information in detail, should we want to. So what is the next step? Well, this is where the mundane stuff comes into play. We're going to do pretty much this. We're going to change up the algorithm. We're going to retrain the whole thing. We're going to evaluate it and keep going at it until we find a prediction or a model that we're kind of happy with. And depending on what this is, it might take a longer time or a shorter time. It's completely dependent on what you're working with. So how can we implement this? How do we actually use this? Well, there are a couple of ways, and one is the most obvious one, and this is the web service. This is just an endpoint that I give data and it returns a prediction. This can be either, for instance, on the web, just use it in a web browser, or you can connect it to the single most dangerous piece of software ever devised. Yes, I'm talking about Excel. So for instance, we could have one of these columns in Excel to send data to a machine learning algorithm like on a web service. There's a great demo on gold, diamonds. In order to classify and set a price for a diamond, there are a lot of different properties that needs to be reviewed. The size of the diamond is the obvious one, or actually the weight of the diamond. That's in carat. Then you have the color of the diamond, the purity of the diamond, and so on and so forth. There's so many properties, and all these interact to create the nominal price for it. So what if you had all these columns with all these properties, and then a column, a computed column, if you will, that goes and takes the whole row, sends it to a web service with a machine learning algorithm that's going to give you back a reasonable price. That is one way of using machine learning via a web service. Another one is both super cool and pretty darn scary when you think of it. And this is where you have the Azure Edge, the Azure IoT Edge. Anybody ever seen one of these? Yeah, a lot of people actually have these because this is just a normal camera, and this specific camera can run Azure IoT Edge. So this means that I can create a machine learning algorithm. I can train it using all the immense power of the Azure cloud. And when I have my algorithm, I can package it and put it onto this camera. And this camera does not need to have any connection to the internet at all. So using this camera, you can very, very simply create an algorithm that discerns a person from a cat, for instance, Or if you want to work at it a bit more, it can do a pretty good job of deciding that the person ringing your door is a friend of yours or someone that you never met. You can also put them into these things. This is the DJI drone. And DJI drones, the more high-end ones, can all run Azure IoT Edge. One of the coolest demos that I've ever seen was Ignite 2 years ago, when they had a DJI drone loaded with an algorithm to find rips and tears in pipelines, or damages in pipelines, because there are thousands and thousands and thousands of miles of pipelines running all over the globe. And I'm pretty happy with my job, but I don't think that I want to change jobs and be a pipeline inspector that basically gets to go out and walk these thousands of miles just to look at the pipeline. So enter these things. You can send them out en masse. Just go out and watch the pipelines. And they had a bit of pipeline on stage. They had a DJI drone loaded with this algorithm, and they had it damaged one of the pipelines, or the sections of pipe. They sent this out and it immediately highlighted the damaged part. So this can save so much time. Or you can use this for search and rescue operations, which is also super cool. So extremely powerful, but also kind of Orwellian if you choose to do so. But again, it is a tool. It does not care what you do with the tool. So be careful. So how can we use these? Well, I'm going to give you a few quick examples before I wrap up. One is in Power BI. There's actually something called Auto ML, automatic machine learning, inside of Power BI Premium. I can use this to automatically do image recognition or sentiment analysis. In this specific case, it was hotel reviews. So we're using sentiment analysis on free text to get a number from 0, which is extremely negative, to 1, which is extremely positive. What are people saying about hotels in Hawaii? That means that we can say which hotel is popular, but we don't know why. But it turns out that a lot of people who had done these reviews also attached pictures. And if we can do image analysis and figure out what's on the picture, we can correlate the picture with a negative statement. And it turns out, as you can see, the most negatives were about AC units. And that kind of makes sense in a state that is extremely warm. So top tip, if you're running a hotel in Hawaii, make sure that your AC units work, are not full of mold, and not very noisy, because that's going to drive down your sentiment. Makes sense. You can use AI for quality. There's a German company, DB Berater, that does machine learning algorithms to fix data. My city is 160,000 people. It's a pretty small city, and I have electrics. We have water. We have so power, water, internet, and that kind of stuff. I have at least 3 different accounts, where I should have 1 because it's the same darn company. But in one account, my name is spelled slightly wrong. And one account has slightly wrong spelling of the street. And for a human, this is obvious. For a machine, not so much, especially if you have 100,000 rows, right? This company does this kind of a fuzzy matching, which is extremely cool. So that is a great way of using machine learning for really increasing the quality of your data. Now, I don't know about you guys. I don't enjoy huge heights. So I could never be working as a serviceman for wind turbines. And when one of these things fail, it is pretty expensive to ship out a new gearbox. Or if, God forbid, it failed catastrophically and the whole rotor fell down, I just hope that nobody's going to get that thing on their head. So what Vestas of Denmark did was they put in microphones in all their gearboxes, and they have recorded millions of hours of normal gearbox sounds. They now have a machine learning algorithm that crunches this data and gives a prediction based on the sound of the gearbox. Is this gearbox going to fail within a set amount of time? So they can do predictive and preventive maintenance using a machine learning algorithm, and this has saved them like a gazillion dollars. And then we have my absolute favorite thing. I told you I used to be a paramedic, right? Now, one of the most difficult things that you can face is you need to diagnose something very, very quickly at an accident site. And it can be very noisy, or you might be in an ambulance trying to listen to a heartbeat or breathing, whatever it might be. It is difficult for me to do auscultation, and it doesn't matter if I'm extremely experienced or not. It is difficult depending on the outside noise. This thing that costs $500, it started as a Kickstarter, can do that work for you. It is a Bluetooth stethoscope that you can put in the hands of anyone, and it is not only going to be recording the audio stream or whatever it's listening to, it's going to enhance the audio, and it is going to give you some kind of interpretation. And of course, you can always send this to someone who is qualified to do an action interpretation. So this means that you can not only use this at an emergency site, you can put these in the hands of people in the third world. And you can use this piece of technology to really, really save lives. So this is super, super cool. And again, this is $500. It's available today. So in summary, machine learning is a tool. Keep that in mind. Azure is the perfect toolbox because there's so many awesome stuff in Azure that you can connect to machine learning. And we've only scratched the surface. There's so much more. Again, this is just for beginners. My goal was to give you a primer of what this tool can and cannot do. And I wanted to get you on your way towards learning how to do this and how this tool can benefit you in solving your problems. And machine learning won't cure cancer. We've seen why in this session. Now, either of you might, with the help of machine learning as a tool. Where a screwdriver or a hammer has a fairly defined usage area, we have yet to probe the full extent of what we can do with machine learning. It's up to you to find where you can apply these things to your problems. You now have a primer on machine learning, but believe me, when I tell you, you ain't seen nothing yet at all. My name is Alexander, and I thank you so much for your time. Jason, all yours.
Oh, sorry about that, Alex. I had double muted myself.
Double muted. That's serious.
Yeah. So let me get to the first question here. Is there any documentation to know which model to apply to data for prediction?
Oh yeah, there are like literally miles of documentation, and this is one of the primary responsibilities for a data scientist, and that is a function of what are you trying to predict, what does your data look like, how much data do you have, and so on and so forth. So I would definitely go just Google how to choose the best algorithm, and then you're going to have food for thought until next Christmas easily.
Okay, and then any tips for date range for, say, customer churn, or what could be external factors?
Those are very valid questions, and also pretty far away from beginner stuff. Again, look at, let's see, what's Leila Etati There are two amazing MVPs in New Zealand, Leila and Reza. They're both married. Reza is a Power BI MVP or data platform MVP, and Leila is an AI MVP. She has written a lot of stuff on applications for AI and machine learning stuff. So I would definitely start with her blog. Just Google Leila Etati and you're going to find it.
All right. And that actually covers the questions that we had.
Oh, there we go.
Yeah, so sorry, I kept muting there and then it didn't come unmuted. So those are the questions we have for today. So Alexander, thanks you for presenting. This has been great. And
thank you very much for having me.
I really like your slides.
Thanks.
All right. Well, thanks again, and thank you everyone for attending. And with that, everyone have a great rest of the day.
Take care, guys.